Some of the decisions we have to make when writing computer programs cannot be expressed with one relational expression. In those situations, we have to combine more than one, two or more, into what's called a logical expression using what's called a logical operator. The logical operators are AND, which is signified with two ampersands, OR, which is signified with two bars, or NOT, which is signified by the exclamation point. Let me bring up a table to show you how the logical operators work. You might remember this from your high school or college math courses where you were working with logic. These truth tables demonstrate how the AND, OR, and NOT operators work. In the table you'll see that I have, well, at least for AND and OR, we have an RE1, which is relational expression 1, RE2, which is relational expression 2, and result, which will be what happens when we combine the logical operator with the two relational expressions. So if you look at the first table for AND, you'll see that if RE1 is true and RE2 is true, then the result of both of those is true. In other words, RE1 and RE2 means true. If RE1 is true and RE2 is false, then the whole expression is false. In the third line, if the first expression is false and the second expression is true, then the whole expression is false. And then finally in the last line, if RE1 is false and RE2 is false, then the result is that the whole expression is false. Moving down to the truth table for OR, we see that if RE1 is true and RE2 is true, then the whole expression is true. If RE1 is true and RE2 is false, still the whole expression is true. If RE1 is false and RE2 is true, then the whole expression is true. And only if RE1 is false and RE2 is false is the whole expression false. So ORs end up with a lot more true results than ANDs do. And finally we have the truth table for NOT, and NOT is simply a negation of a current expression. So you see we have a relational expression and a result. In the first line, if the relational expression is true and the NOT operator is applied to that expression, then the result becomes false. And vice versa, if the relational expression is false and the NOT operator is applied, then the result of that is true. Let's look at a couple of examples of using logical operators in C++ code, but we're going to have our best results when working with if statements, as we'll start in the next lesson. I'm going to create a couple of variables. Hours worked as an int equals 40, and hourly rate as a double, which we'll set to 9.75. So we're going to write a logical expression that states hours worked less than 1, or, and that's the two bars, the bar is a shift over the backslash, hours worked greater than 56. So, for this expression to become true, either one of the sub-expressions, hour worked less than 1 or hours worked greater than 56, must be true. Either one can be true for the whole thing to be true. Let's see what we get when we build and run. That's false, because if we go back and look at the value of hours worked, it's 40, which is greater than 1 to make the first sub-expression false, but it's less than 56 to make the second expression false. So a false or false is false. Let's look at another example. In this case, we'll write hours worked less than equal to 40. And hourly rate less than equal to 10. Also notice that each sub-expression is also surrounded in parentheses. That helps make the expression easier to follow and understanding that there's a single result from these two sub-expressions combined with the logical operator. So let's build and run this. See what we get. And we get a true. If we go back and inspect, we'll see that hours worked less than or equal to 40 is indeed true, and hourly rate less than or equal to 10 is also true, since the hourly rate is 9.75. Just to demonstrate how NOT works, we'll do one example. So to write the NOT, you put it in front of an expression like I've done here. So we're saying cout NOT hours worked equals 40. Remember that NOT simply negates the result of the expression that follows it. So we build and run, and we see that it's false. Because the original expression, hours worked equals 40, is true, so not true is false. As I mentioned earlier, we'll be able to understand the logical operators a lot better when we get to the point in this chapter where we study if statements, where we can actually see the use of logical operators with more meaningful code.